Okay, so now that we know that all of the food that you eat, right, we're not using 100% of that to actually grow our cells or to get energy to do things like go for walks or think or blink or breathe. But most of it is actually going to be used to keep our body temperatures as is and to actually be able to digest our food. So how much energy can be transferred then? Well, from each trophic level transfer, okay, so going from, let's say, producers to primary consumers, only 10% of the energy is transferred for that organism to actually use. So what happens to the other 90%? So 90% of the energy is used for those exact two reasons we just mentioned, for energy to heat up the organism's body and to digest the food itself. Digestion. We can't see the red too well. So the most ecosystems can have a maximum of 5 trophic levels. Now, this is not like a make or break rule. You could have some organisms with 6 or more, but it is very, very, very rare to have more than 5. The reason why is actually goes back to the fact that only 10% of the energy is transferred. So you have to imagine with each trophic level transfer, there is less and less and less energy available. So eventually it gets to the point where there's not enough energy to support the consumers that are at the top, right? So let's say I had, we had grass. Let's say then I had some sort of insect. Okay, then I have, let's say, a frog. And then let's say I had a hawk. Okay, hawk eating the frog. So let's imagine that the grass has, and the unit for energy units are called joules. Okay, sometimes a capital J is the symbol for that. So it's kind of like when we talk about mass, right? You can say something has 100 grams. Grams is the unit for mass. Energy units are called joules. So when we talk about the energy that an organism has, we'll always mention it as joules. So let's say grass has, 100,000 joules of energy, okay? So when it goes to the insect, remember only 10% of the energy gets transferred. So that means that now this insect has, right? So basically you would take this and divide it by 10. Now it has 10,000 joules, right? And then when we go from insect to frog, the frog has only 10% of the energy available from the insect. So again, you would take this number and divide it by 10. So now we would only have 1,000 joules of energy for the frog. If we were to look at another transfer to the hawk has only 10% of that 1,000, which means it would have 100 joules. So imagine with each level that you continue on, maybe, I don't know what can eat a hawk. A large hawk. A larger hawk. Just to give you another example, right? So 10% transfers there. Now you only have 10 joules available. Imagine there was another level, you would have only 1 joule of energy available. So even though it seems like, oh my God, there's so much energy at that first trophic level, by the time you hit the top carnivore, there's actually not much available. That's actually why usually top carnivores have to ingest a lot more food. It's not necessarily because, the hawk is hungrier than the insect. It's just because it needs more food to get enough energy to actually survive. Whereas if this insect is eating grass, it does not have to eat a lot of grass to get a substantial amount of energy. It's because it's closer to the start of that food chain. So that's why for us as humans, what's more efficient to eat, right? It's actually fruits and vegetables. You get more energy from eating fruits and vegetables than you would eating, not like you would eat anything in this trophic level here, but let's say you were eating a hamburger or something, or a piece of chicken, or a piece of fish, right? You get more energy from eating fruits and vegetables and grains that are producers than you do from your meat products. Now, that doesn't mean that it doesn't have a place. Obviously, the autotrophs, if you eat a producer, doesn't really have a ton of protein in it. So there's a reason why we eat a variety of foods in our diet. But let's say, you had a choice and you are feeling kind of sluggish. Usually, actually, maybe you do or don't know this, but typically people who are going to run a marathon or they're going to go long distance running, they will eat more carbohydrates or producers, so like things like rice and pastas that are made from wheat. They'll eat a lot of those the day before they go for their long run because that's going to give them a lot of energy, right? So just something to kind of think about. But 10, the key there, the magical number to remember is 10%. Only 10% is transferred through each level. So this is just kind of like a visual for you to check out what's happening here. So the producers are getting their energy from the sun. And remember that the food chain continues up through the trophic level. So here's trophic level number 1, trophic level number 2, number 3, and number 4. So this is just a representation showing you that there is less and less and less energy available as you go through the different levels. Okay, remember that magical number is 10%. So 90% of the energy is lost in terms of heat, right? Heating up the organism and through digestion. Okay, so let's talk about an ecological pyramid or an energy pyramid. So this is similar to what we're going to be doing. See how it's kind of in a pyramid shape? It's half a pyramid. Anyway, what we're looking at here is just like a visual representation to show energy flow in a food chain or a food web. So the key to remember when you're looking at pyramids of energy is that 10% of the energy is brought to the next trophic level. 90% of the energy is lost. So the level that should have the highest amount of energy is always trophic level number 1 with your producers. So here is a picture for an energy pyramid. So first of all, I want to point out something that's actually incorrect in this picture. This bottom level, see how they're showing you the sunlight amount of energy? Technically, when we are doing an energy pyramid, we only do the food chain organisms. So the sun, even though I understand the point of having this in the picture, they're trying to tell you that the producer gets energy from the sun. But the food chain always starts with trophic level number 1, right? Which is our producers, okay? So technically, the sun is not a living organism, right? So only living organisms that are in the food chain go into an energy pyramid. So if you notice, the first level has the highest amount of energy, right? Which is your producers. Primary consumers are in trophic level number 2. And notice this is 10%. Right? So went from 10,000 joules to 1,000 joules. As we go to the third trophic level, our secondary consumers, right? Only 10% again gets transferred. And then here we have our top carnivore. In this case happens to be a snake, our tertiary consumer, which again has 10%. So they call it an energy pyramid, right? Because technically the shape gets smaller and smaller as you go towards the top. Okay, now there's 2 other types of pyramids that exist that I want to mention here. Okay, so one is called a pyramid of numbers. Okay, and your textbook talks about this as well. So what this is you're still showing trophic level number 1, 2, 3, 4, etc. I'm just going to do 3. But instead of doing, see how this has the energy number? What they're going to do here is they show based on the number of organisms. So let's say if we had grass, let's say we had 200 blades of grass, right? So this would be 200. And let's say we have, there are 5 squirrels, right? So it's like literally like how many blades of grass, how many squirrels are there? And maybe there are I don't know, there are two owls, let's say. Okay, so pyramid of numbers. But sometimes it doesn't always look like a pyramid. I'll give you an example. Let's say we were looking at an ecosystem. We'll do the same thing, 1, 2, 3. Let's say we were doing an ecosystem that had only 3 oak trees. And then in that oak tree, maybe there are 100 ants living on those 3 oak trees. And then there could be maybe 2 owls there or something. So you see how this, like, the shape is kind of different? Pyramid of numbers does not always take on this shape because it literally depends on the number of things that are there. So if there's only 3 trees, the bottom level is going to be small. Whereas here there's 100 ants, it could be bigger. So it's kind of like a lopsided shape. But pyramid of numbers is used sometimes. Pyramid of energy is the most common. Okay, so that's the one that we spend the most amount of time talking about. And there's one other type. It's called a pyramid of biomass. Okay, so what a pyramid of biomass is imagine how heavy all of those organisms are. It's like the mass of those things. So for example, I'll use the oak tree one. Let's say those 3 oak trees are really heavy. Maybe they are 100 pounds each. So we have 300 pounds of oak trees, right? It's literally talking about the weight of them. So if we had 100 ants, ants are very, very tiny. So maybe the 100 ants all together maybe are 10, not even, I think that's too heavy. I don't know how much 100 ants would be. Let's say it's 1 pound. I have no idea, I'll be honest. I've never weighed an ant before, but let's say all those ants, the 100 ants weigh a pound, right? Well, like those 3 oak trees are huge in comparison to the 100 ants. And then 2 owls, maybe each owl weighs 5 pounds. So the owls might be, 10 pounds worth of owls, right? So pyramid of biomass, again, is not used as often because it kind of shows wacky shapes because it literally depends on how heavy are these things that we're talking about. So I did want to mention these other 2 types. Not able to see that properly. Okay. So I did want to mention pyramid of numbers and pyramid of biomass just so you have an idea of what they are. But pyramid of energy is the #1 type of pyramid that is used for ecological studies.